The lecture of Chapter 12, Section 2 on soil, and again, disregard the fact that it says 5.2. I took this lecture from a different book. Characteristics of soil. Soil is part of the regolith that supports the growth of plants, and a regolith is a layer of rock and mineral fragments that covers most of the Earth's land surfaces. Soil composition. Soil has four major components: the mineral matter, or broken down rock, the rock fragments; the humus, which is the decayed remains of organisms or the organic matter; water; and air. What it looks like graphically in a pie chart: most good quality soil is 45% mineral matter, 5% organic matter or the humus, 25% water, and 25% air. Characteristics of soil. Soil is classified or characterized by its, number one, by its texture, and the soil texture refers to the proportions of different particle sizes. I can remember from my soils days in colleges that when you're always feeling it. You're feeling it for the sand, the grittiness, the siltiness, which is a characteristic. To feel the silt, it would feel like talcum powder, and clay. Does it stick together just like your clay, classroom clay or Play-Doh does. The loam content is a mixture of all three sizes, and this is the characteristic that you're looking for, and it's best suited for plant life. Here in Wisconsin, we have a state soil that is the Antigo silt loam, and if you've been in and around Antigo, you know that they grow a lot of potatoes in that area, and Antigo silt loam has been identified as the state soil. This graphic, very familiar to me back from my soil class days. It's used to classify soils by the texture, and as you see from the pyramid, you have clay content at the top, the sand content the left corner, and then the silt content at the bottom right corner. And depending on the composition, and this is up to the individual classifier, you can determine what type of soil you have, and then there's further classifications to break it down even further into the different characteristics. So for example, this sandy clay that's been identified, it would, if I look at this sample A, I'd see that I have 40% sand. I've got about 10% clay, and if you follow that up across, about 60% of the silt, but it tends to lie in that percentage of 40% clay and about 80 to 90% sand. So you'd have what we characterize as a sandy clay with very little silt content. Soil is also classified by its structure. Soil particles clump together to give soil its structure. And soil formation, most important factors in the formation of soil are the parent material. Where did it come from? The time it took to make the soil, the climate, how much rain do they get, how dry is it, organisms, what animals or plants are present, and then the slope. Where was the soil deposited? What is the topography like? Is it flat or is it on a hill? Parent material of soil. Soil, again, is classified according to where it was deposited. Residual soil. Parent material is a bedrock. It means it's in situ or was deposited in place. Transported soil. Parent material that has been carried from elsewhere and deposited. As I said earlier, we can thank Canada for the majority of our soil in Wisconsin. It was brought down by the glaciers. This graphic indicates the difference between residual and transported soil. And to the left, if you look, we have residual soil that develops on the bedrock. In the middle part of the graphic, unconsolidated deposits in the plains. And then, of course, in the bottom, if we do a cut, you can see that the majority of the soil in the what we would call a fertile valley. If you characterize this as the Mississippi, although this is a young river by the graphics, so not like the Mississippi, but in the fertile plains, the floodplain along the river, you have transported soil or unconsolidated deposits. That means it isn't stratified as much as a residual soil would be. Soil formation, again, time. This is important in all geologic processes. And the longer a soil has been forming, the thicker it becomes. Climate is another factor. This is the greatest effect on soil formation, the climate of where it deposited. As you've seen earlier from the Section 2 read, we're in the moderate temperate forest region here in Wisconsin, and it means we get enough rain and enough moisture that's conducive to the growing of trees. Organisms influence the soil's physical and chemical properties. They furnish the organic matter to soil, or the humus. And again, the slope is the angle. How steep is the topography? Steep slopes often have poorly developed soils, and the optimum slope is a flat to undulating upland surface like we have in Nebraska, Iowa, Kansas. We grow a lot of corn and wheat in that area, and we've got good soil because it is flat and fairly flat with some undulation, or which means some hills. Slope. The orientation or direction the slope is facing influences soil formation too, and the orientation means, how much sun is it getting, how much temperature, what's the temperature and the moisture. A soil profile. Soil profile, by definition, is a vertical section through all the soil horizons. Soils vary in composition, texture, structure, and color at different depths. Soil horizons are the zones or layers of soil, and we've learned that there are basically three horizons. The A horizon is known commonly as topsoil. The B horizon is subsoil. Contains clay particles washed out from the A horizon, typically with a reddish color because of the iron content, and the C horizon is between the B and altered parent material or the bedrock beneath it. This is a graphic illustration of a typical soil profile. Again, the A horizon, the topsoil that we have, and the A horizon is right here, darker in color. The B horizon, or the subsoil. And again, this graphic is a little out of color. This should be, let's see if I can get a red pen here. There should be more red or rust in here. Okay, the clay has leached down and it oxidizes and is typically weathered. And then, of course, the C horizon. Partially weathered. This is where you're going to find more of the rock material as this bedrock weathers. A soil profile shows different horizons, and again, we can go through and we can start to identify the topsoil, up here, that layer. Here we've got the B horizon here, and then the C horizon down here. This would indicate the C horizon. You can see the rock fragments and sitting on top of what we refer to as the bedrock. Soil types. There are three common types of soil: pedalfer, pedicle, and laterite. Pedalfer soil that's developed under forest vegetation, like we have here in northern Wisconsin. And this soil is characterized by the accumulation of iron oxides and aluminum-rich clays in the B horizon, or the middle horizon. A pedicle soil accumulates calcium carbonate associated with drier grasslands. As we were to move westward across Mississippi into Nebraska, Colorado, parts of southern Minnesota, you're going to see more of this pedicle type soil, it's associated with like drier grasslands, the central plains, or a prairie environment. And then laterite is the hot, wet tropical climates and intense chemical weathering. And you can see this type of soil, especially around Florida and as you move closer to the equator. Soil erosion. Water erodes soil, and the rates of erosion are controlled by human activities that remove natural vegetation, such as farming, logging, construction, and they left out mining. They have greatly accelerated erosion. I can tell you from experience, though, that modern mine plans call for the reclamation. That was my major in college. Reclamation of the mine site. Even before you start the mining operation, you have to have a reclamation plan in place nowadays because of mistakes we made in the past. Another contributing factor to soil erosion is sediment deposition. The reservoirs fill with sediment, and you've seen this in our Gold Rush series, where they have their reservoir, and because they haven't controlled erosion, their pump is constantly filled up with sediment. Sediments are contaminated by pesticides and fertilizers. Once again, that human influence. Controlling erosion. Any of you that have traveled across Wisconsin can see that. Farmers are pretty good at controlling erosion. They don't want to lose their soil, so they plant rows of trees called windbreaks. If you travel Highway 51 from, say, like Wausau to Madison, you'll see plenty of these windbreaks along that highway, controlling the movement of soil across the highway from one field to the next. We also terrace hillsides, the contour plowing, and that is the next step there, plowing along the contours of hills. And then crop rotation. You've often seen like fields where there'll be corn one year and then maybe soybeans the next year, or nothing the next year. And I just wanted to graphically illustrate what that contour plowing looks like. Say a farmer has a field that basically runs north to south. Come on, what happened? Say he has a field that runs north to south, and say that the slope water would run down the hill. What a farmer will do when he plows is he plows his rows kind of in this pattern. And look once, even in and around Green Bay, when you head out maybe Highway 43-ish towards Denmark, you can see where the farmers plow, and this means so that as the water were to flow down the hill, it's trapped by these furrows, so it doesn't just continue to run. And that concludes the lecture notes for Section 2. Section 3 will cover mass movements. Again, check your My Big Campus account, and there will be an online review activity for Section 2.